on a home in Mesa, Arizona, and we're looking at this foundation, and right below this window, and this is the very beginnings of oxidized rebar reinforcement steel. This little hairline crack, once it starts, and the reason why it occurs to begin with is the interior reinforcement steel has moisture around it and oxygen is getting to it, and it's made of steel, so you get those three components and it starts a low voltage electrical current. You can see this patch material has been patched over before. It's starting to come apart as well. So we have a 3-foot space right here that we're going to tear into, remove that steel, replace it with the new number 4 bar that's coated with rust inhibitor epoxy 2 component. My guys are over here on this side, and here is a wing wall just off of the garage. And just something that I notice all the time is a lot of times the garage doors shut tight right in the middle. This doesn't have a control joint there. But it usually sits tight and then has a gap on one side or gap on the other. And you can see that because of this crack, this side is going down. And there's stair stepping in the block on this wing wall. And the reinforcement steel has rusted down 20%, at least 20%. So we're removing this number 4 bar, which looks like a number 3/8 rebar right at the moment, because number 4 bar should be much bigger, 1/2 inch. So it expands, breaks out the entire side here, and can cause structural damage. Over here, the rebar has been removed, and we're going to reinstall another piece. This guy here, he's putting on our glue coat on our virgin material since we've chipped into everything, and once this is done, we install the rebar coated with epoxy rust inhibitor. Over here, the same thing. We've removed the rebar out of here, and you can see by the stair stepping in the block right here at the weakest part of the walls, doorways, windows, and thresholds. From this point this way, this side's going down, and we're not going to be able to view it on the interior floor, but the floor is actually heaving up, causing huge interior floor fractures on the interior. Here's another area. When rebar oxidizes, it expands up to 5 times its size in diameter, busting out this side of the stem wall foundation here in Mesa, Arizona. We have to be very concerned, even though we live in Arizona. It's an arid climate. It hardly ever rains in Arizona. Hardly anybody's got any rain gutters. Why should I have to worry about water in Arizona? Well, here's why. We're at the bottom of the foundation right here. The foundation's here in Arizona because it is not a freeze and thaw climate like northern territories, and the footings are a lot deeper up there to get below the frost line. Here, they're very shallow. So basically, when the water has an opportunity to saturate the soil that's holding up a home and has a shallow foundation, just imagine a 10-pound bowling ball on top of mud. And it starts the stair stepping in the walls, in the blocks, the interior floors start to heave up. This is the reason why most every single floor, tens of thousands of homes that I have viewed in 35 years, have interior floor heaves. It's not because, oh my God, my house was built on expansive soil. That story has been told for years and years. I prove it wrong on a daily basis by evidence. For more information about interior crack grinding, crack stitching, floor heaves, doming of interior floor, triangulated fractures, settlement of your foundation here in Arizona, contact James at 602-418-2970, or you can always go to concreterepairman.com for more information. Thank you so much for watching, and I hope this has helped you so you can view some of these issues around your house. Please give me a call. Thanks for watching, and have a great day.